this is for Year 11 methods. We're going to look at exercise 5D, question number 8. Okay, so it says draw a graph of this function. It's all reals, domain's all reals. By restricting the domain, okay, so we need to draw the graph of this first and then we'll restrict the domain. So we'll do A first. Okay, so to draw the graph, this is a quadratic, okay? So remember, you can treat the f of x like a y, right? So before we draw a quadratic, I like to get the turning point form first. I'd get in turning point form. So x squared minus 2x plus 4. Oops, write that. X squared minus 2x plus 4. I want to get that into turning point form, so I'm just going to scaffold. So this will be minus 1, and then 1 there, and then you can add 4. So I know that I've got x minus 1 squared plus 3. Okay, so the graph is going, the correct graph is shifted 1 unit to the right and 3 units up. This is useful to get the turning point form straight away because I know that my turning point's there and it's going to be a smiley face, so I'm not going to even get any x-intercepts. So all I need to do is find where my y-intercept is. Y-intercept x equals 0, so f of 0 equals, so function notation, you're trying to find f of 0, it happens to be 4. Okay, so we're y-intercept at 4, and we have an x turning point at 1, 3. So it's going to look something like this. Okay, and that should be okay. Just make sure the graph is roughly proportional. Even this, my graph isn't perfectly proportional, so just be wary. I might change it just so that I practice what I preach. So if I go here, that might be a bit more proportional. So this will be 4. Okay, so it just gets the graph, and you can label that f of x. It's like a y, and that's x. By restricting the domain, form two one-to-one functions. Can you see this is not a one-to-one function simply because if I do a horizontal line test, it will fail it. Okay, so you want to get cut only once. Now the only way you can do that is if you split the function into 2 bits. Okay, so I'm going to use a highlighter. That's your first bit. Okay, and this is your second bit. Okay, so you're splitting out the turning point. So I can form the function f, same rules f. So I'll call it g such that from, okay, the blue would be from negative infinity to 1, negative infinity to 1, I'll include 1, to reals such that g of x equals to the same, it's the same equation, okay, but it's just, I've restricted the domain. 2x plus 4. Oops. And h, I'll call the second function h. It goes from 1, so it's yellow, 1 to infinity, going to reals, such that h of x equals x squared minus 2x. What the question was essentially asking me to do was to simply draw the graph and split it into 2, so it's 1 to 1. Because if I look at the yellow, it passes both vertical and the horizontal line test, so it's a 1 to 1. Same with the blue, okay? And you just define the function that way. Hopefully that helps.